Hello class and welcome to the chemistry lab. Carlos and Ryan, I'm at your lab bench from 221. So look familiar? And I'm at their lab bench because it has the board and I'm going to walk through QA1 with you. It's a pretty simple lab, and so you guys are going to, from reading from this, you'll be able to answer the post-lab questions, and then you're going to make a flow chart. So we're going to walk through that. So the first step is we put our stuff in the centrifuge tubes, and then I add 2 drops of HCl. I should have done that in front of the video. But what happens is it becomes white and cloudy, which means we have a precipitate. So it started out as a clear solution, which we can see in our lovely bottles. Now we can stand here and wait and wait and wait for the precipitate to settle so we can separate it, or we can put it in our easy bake oven. It's not actually an easy bake oven. It is something called a centrifuge. And the centrifuge is something that goes round and round and round and round and round really fast. And by going around really fast, it pulls the solid down. So the flow chart, as that slows down, we have our starting point. Every time you do something, you're going to use either a shape to show the step or a different color. And we'll try the blue, how it works. So the first thing I did was I added HCl. So these are called the group 1 cations because they're the only cations that precipitate with chloride. These are the 3 heavy metals. They also are the ones that mess up your brain. So lead and mercury, right? Mad as a hatter. So I have my mad hat on. All right. So I add the HCl, and what happens is you now have a choice. And we're going to put through our centrifuge. We'll do this red, means my centrifuge. You can make up whatever symbol you want. And when I centrifuged, oops, I have a few floaties. I don't know if you can see on the camera. It's clarified it mostly, and I can use my handy dandy pipettes. Action. And transfer the supernatant. We want the precipitate. So this white stuff that's in the bottom. The supernatant we're going to actually do nothing with. I'm not going to do anything with. I'm going to throw it in the waste. So let's go ahead and fill out our flow chart. Actually, we're going to do the next step, which is we're going to add a little bit of water. Clean pipette. And we're going to mix. And another clean pipette for our other sample. And we'll get our precipitate all in there, and we're going to put it in hot water for 2 minutes while we work on the flow chart. All right, so what happens is we separate it. And on one side, we get the precipitate. So the precipitate is the solid. Let's see if you see it over here. So PPT is the solid. And I'm going to use a symbol for it, like this is my rendition of a rock. It's just sitting there. It's like a pet rock. All right. So this would be like my chart over on this side. So this is my precipitate, and it has the group 1s. And what I just got rid of, and make a raindrop. This is my supernatant. So it talks about this in the lab a little bit. So precipitate, every time we centrifuge, we're going to separate. And the liquid is called the supernatant. It's actually the solution on top, but I'm going to write liquid for right now. The supernatant, we're going to do nothing with. And you know what? I just realized I used green, and you guys don't like green. Let's try the supernatant with blue. So that's our SUP for short. And probably also not showing up. This is gonna go in the garbage. This would go to be tested for group 3 and group 2. We're not gonna do group 3 today. And it's heating away. Now, what happens is our next step, and I'm gonna use black for all this so you guys can see what I'm doing here. You can see me a little bit. Is all we did was we added some water and then we added heat. So that's a flame. All right, next to it, heat. And then we're gonna centrifuge again. So let's do our centrifuge. We can do that in green because we can't see the green. It's too bad, green is one of my favorite colors. All right, so we're centrifuging and then we're gonna split again. So again, we're gonna have a precipitate. So you can have a symbol like a chocolate chip cookie and a glass of milk. It can be your supernatant. I'm going with the raindrop. So around our lab are all these amazing tables that students have used in the past, have made in the past, and they often come up with a theme and stuff. But in this case, after we centrifuge, so again, this is my precipitate, and if you want, we can write PPT. Our next step that we're gonna do, and again, you would show this, every time you do a step, you show it in a specific color. Every time you have precipitate, you have a shape that shows that. Is to the precipitate, we're going to add potassium chromate. I am sorry, I got that backwards. To the supernatant, we're going to add potassium chromate. And we're going to see one of two things happen. So either we're going to see yellow cloudiness, so I'm going to call it a yellow precipitate. I'm just writing PPT for precipitate, or it's going to be yellow clear. The potassium chromate is yellow. Precipitate means yes, we have lead. This is our test for lead in lab. And no lead. Which actually might be a good thing. Poor lead. Misunderstood, but it does cause brain issues. So let's go ahead and try it. All right, so we're gonna take this out of our hot water. I know I'm off screen because I'm burning my fingers. Easy bake oven. Count. Sing the alphabet backwards. ZYX. WVU, TSR. All right, we're good. We wait for that to come. And we're going to separate. So we're going to put this in another tube. I have my 2 test tubes. And here we go. All right, so again, we separated. I don't know that the camera picks up the precipitate. Not really well. All right, clean pipette. And put the supernatant in another tube. I'll keep my I have 2 samples because I want to show you what the yes-no means. All right, so these are my supernatants. Left the precipitates for a next step, which I believe is step 3 in your instructions. Oh, and immediately we see a difference. So they're both yellow, and one of them is definitely cloudy. This one has lead, and this one, it's not cloudy. And so we have a yes and a no. And so this is what people do when people bring in hazardous waste. This is a really simple test to test if you have lead. But you have to pull out the silver and mercury. So what happened with the heat is the lead chloride is soluble once you warm it up, whereas the silver and the mercury chloride are not. Again, no other cation will precipitate with chloride. Who figured this out? Who knows? But it's awesome, right? All right, do you want to feel like you're part of the action? Look at that, test tube rack. I have to get really low. All right, so back to our precipitates. We add a little bit more water. Dilute it a little bit. And we want to try and, in the instructions, you would clean it, do all that good stuff. If you guys were in lab. And what we're going to do to this is we're going to add some base, NH3, which you all know now, nitrogen. See the NH3? We add NH3, 2, 3, 1, 2, 3. And, oh, we have a result. So one of them definitely has that grayish hue. You can see the black precipitate forming on top of the white. And the other one still just has a white precipitate. So let's go back to our flow chart. And we're over here with the precipitate. Again, you guys can use different colors. So at this point, we added some NH3. And you're going to have a yes, no, like we did over here. So the gray color means yes, we have silver. I'm sorry, no, yes, we have mercury. All right, we want to separate it off, and we separated it off. Into my sample that's left, I want to acidify it because the NH3, the silver will usually dissolve in a basic solution. So we want to re-acidify by adding a few drops of HNO3. And the way we test to see if it's become acidic, that was the noisy glassware drawer, which Ashley will appreciate this because she worked in the labs, and they're really beautifully and clean. Nobody gets to use them but me, but we can see it precipitated again. But we can show that it's acidic because when we touch the litmus paper, this was blue litmus paper, and it turns pink, which means it's an acid. And there we go. So our sample had lead, mercury, and silver. Although the one sample did not have any lead and did not have any mercury, but it did precipitate. So if you've rolled out the lead and you've rolled out the mercury, it must have silver. One other real quick comment, and then maybe we'll see if we can walk around the room and see some of these charts, is, well, I see the Valentine's my class made in February still on the wall. That's awesome. Mercury is a diatomic cation. It's the only one that I am aware of. And that's why it is mercury 1, but there's always 2 of them together. And so the 2 together make it a +2. That is a common question students have. All right. And that's it. QA1. You guys answer the post-lab questions and you make a full flow chart. Now, my flow chart course is not complete and it's kind of lacking in some of these areas. You want to do a very creative flow chart. So I'm going to turn you around. You can gaze at the lab as I run around with this big crate. Oh, look at that. Do you guys see the whole lab room? Isn't that awesome? I had some really cool flow charts on the wall here. Some people, so if you want to go for like a couple bonus points and you want to let your inner child play, oh, they did like a penguin theme here. Imagine that. This person here did a fun ladybug theme. Now, these flow charts are a combination of both QA1 and QA3. So they have more steps than what you're going to have. This person here, they're kind of thumbtacked to the wall, but you get the idea. They did it on the computer. It's a lot of work, but I want to point out that there's different shapes. I don't know if you can see it. My camera is in focus. So different colors mean different things. So the blue circle is a result. The red is no, the green is yes. Backing up, the brown rectangle was anytime they did the centrifuge, it looks like. Or no, I'm sorry, the diamond was the centrifuge, and then precipitate was always the brown, and the supernatant went towards the blue row. And so you can see it flows out. This person, this was last year. I have no idea how the Blazers are doing, but they did basketball for precipitate, and the hoop was their supernatant. And you can see they have their flame, and yes and no. So you can have fun. If you want full credit, you got to do the post-lab. And you got to make a nice flow chart. And you can have extra fun with your flow chart. All right, 15 minutes is up. Got to go. Bye.